Good morning, everyone. Am I audible?
Yes, ma'am. Good morning.
Yes,
So, I just want to tell you that tomorrow I will be taking a quiz in class on good morning on software development life cycle, what all we have gone through, and also some questions on understanding the problem and problem analysis. So, it will consist of both multiple choice questions, fill in the blanks, match the following also, and subjective type questions also. So, I think your class is from 2 to 3 tomorrow, right? So, please be sure that you are there for the quiz. If someone is not able to make it tomorrow or thinks that he or she may not be able to make it up tomorrow, then please inform me before tomorrow begins. So, before tomorrow morning, please let me know. So, your class is there from 2 to 3 tomorrow. So, there will be a quiz in the class from 2 to 3. So, is that okay? Uh, I'm asking, is that okay?
yes, ma'am. Yes, ma'am.
Okay. So, and it will not take more than 1 hour. So, in the class only you are expected to answer it. But if there is any problem that occurs to any student, internet connectivity issues or anything, they have to immediately inform me within that duration. If anybody informs me after that duration, then I might not be able to consider it. So, so please go through the material that we have covered on software development life cycles, and just to check how much you have retained from what we have studied. We will be uh, having that quiz, and your next quiz will be in September, so around 15th of September. So first one is tomorrow. Next quiz of 10 marks will be in the next month. Is that clear?
Tomorrow it will be one exam, and the next week, 15th, will be one exam.
Yeah, September. So next month. After a month again, after we have covered concepts of software design, because next we will be talking about software design. We have already talked about requirement analysis and SRS also. I'll be taking one more lecture, and then we'll moving to software design. So because we have completed software development life cycle, which is quite a crucial part of software development, so uh, and problem understanding obviously. So just to see that we have retained something, and quiz will be there, and the next quiz will be in the next month. Yes. So I hope the distribution is clear. 20 marks is for essay, 10 for two quiz, 20 marks for your SRS, and rest for your final project. Okay, is my screen visible?
Yes, ma'am.
So in next few lectures, we will be discussing about software prototyping. Uh, the theory behind software prototyping, some examples of software prototyping, the importance of creating a prototype of software, and why this practice is generally considered in the software development scenarios. So before I start, I want to understand, what do you understand by software prototyping? So what is your current understanding of software prototyping? What according to you is the meaning of software prototype?
Excuse me. If possible, please share the distribution in the class.
Yes, I.
Software prototyping, as far as I think, is making simple improvements to the mean, a basic MVP, creating a basic MVP to show the minimum uh, capabilities which required by the stakeholders.
Okay. Anyone else? Do you have anyone in the class has the experience of creating any software prototype? Anyone in the class ever had any experience of creating a software prototype? So basically, software prototype is software prototype is basically a working model equivalent to a subset of the product. So it's not the entire product, but a subset of it. The idea behind creating a small subset of the product is to get its basic functional abilities checked, if not at the complex scale, but at a very basic scale, so that the developers have an idea of scaling it further, and also to take the feedback from the people who are directly or indirectly related with the software prototype or the final product. So basically, it is like a toy implementation of a system. It has limited functional capabilities, low reliability, and inefficient performance. Now, think of it like the projects that you are doing in this module. You are not necessarily creating the entire flawless product. Somewhere it is a bit of software prototype only. If you look very clearly, uh, because in the short duration of time, it is not very possible to develop the entire software from scratch. But basically, what you are trying to create is learn the nuances of software development by creating software prototype. So the idea behind creating software prototype is to illustrate to the customers of how the information is flowing in the software or the product and what functionality it is expected to provide. At the same time, it also provides a very potent way to understand what is not currently working in the prototype, because that will lead to a greater understanding of how the developers should go about correcting that mistake. So prototype is one step after the software design. And software designing we will be discussing in detail in the coming weeks. So it basically is something tangible that you can see, and then before you invest your efforts or resources to further develop other components or other more complex modules of your system, it always helps to uh, create a piece of the software and then have a good look at it, review it, and then move about creating the other aspects of the entire product. So that is why software prototype is important. So it is basically not a production code, and depending on the software prototype, uh, it can also happen that the prototype you create may or may not form the final part of the product. It depends on the type of prototype you are creating. So the idea behind is to we have the requirements, you have done the requirement analysis, you have the software design ready, at least at a low, at least a high level design is ready. And then based on that, you create some working piece of the product at a very small level. So that is basically the what we call a software prototype. Now the question arises, why should we bother about creating a prototype? So if you remember, the first time we came across this term prototype was in the spiral model when it was proposed by the scientist who has identified some problems with the waterfall model. Because in the waterfall model, there was no concept of software prototype, if you remember. even in the iterative waterfall model, we were not really seeing any software prototype getting created. It was only much later, it is now 1984 or 86, when the word prototype came and in the spiral model. So as you've seen that after every iteration of a given period of weeks, the prototype was created, the risk was assessed. Only when the developers and the stakeholders were convinced that it was danger free to move forward, then they would go on to create the other prototype. So software prototyping is definitely a part of software development life cycle. They are not isolated from each other. So prototype definitely finds a place in software development life cycle. But whereas software development theory focuses on static behavior of the software, what prototype provides the developers and users and end users and customers, even product managers, project managers says, uh, that gateway to interact with software at a small level. And as humans, we really respond much better to something we can touch, we can see, we can interact with, as compared to something that we read. So, when it comes to humans, our psychology is very much influenced by experimenting, by playing with things. Then we gather a better understanding. So, naturally, that also applies in software development. Unless and until we can interact with whatever we are creating, or sometimes we may have seen that some apps launch their beta versions for the users to test and provide some kind of rewards for people who are using and testing. So, for example, if it's a gaming app, they have not entirely launched in the market, but they ask their customers and first 100 customers who play the game and they promise some reward. What they're essentially trying to do is they have created some version of the software, getting the feedback, and then they will incorporate that feedback into their final product. So software development is always an empirical process. It's always a dynamic process, and uh, prototyping helps us to sort of get develop immunity from the failure of the software in the long term. Most of the softwares do not fail by giving warning. So, in some essence, software prototype reduces the risk of the product failure. But you see, it is not directly reducing the risk of product failure. This reduction in risk is actually indirect because there can be many elements that can cause product failures. What prototyping helps us is sorts of develops a you know immunity because we can see the smaller version of the product, we can get it reviewed and obtain a feedback. Based on that, when we develop our next version of the product, we will be equipped with certain lessons, certain things that did not work out, and then we will try them not to be incorporated in the system. So that is why the risk is minimized. So it's not a direct minimization of the risk, it's indirect because we are getting feedback and review, and we can actually see. So that is why another thing about the fundamental importance of software prototype is that, again, as I said, uh, we are all humans. We literally thrive on interacting with things, being able to see with them, touch them, and really understand what they are doing. Imagine someone talks about a concept to you, and the other party actually provides you the experience of becoming one that with that concept. So naturally, your interaction will be very different. So software prototype provides vehicles for system engineers to understand the environment and requirements problem being understood. Another thing is that before developing a software, you do requirement analysis, right? Based on the requirement analysis, you create some high level design. After the high level design, if you try to create some software prototype, then always go back to the previous stages. If your system or the prototype is not behaving as it was supposed to behave in your head or in your mind, then you go back to your requirements and see that have I missed something over here. So that way, before the big mistakes percolate down the software development life cycle, what you do is by creating prototype, you nip the problem right in the bud when it's small, and that's how you sort of diminish, if not eliminate, the chances of creating mistakes further down. Then it also gives us opportunity to understand the technical weak spots in the solution. And when the prototype is discussed among the team members, everyone can give their 2 cents, discuss, and then equipped with much greater experiential knowledge, they can again go back to develop their software. Prototype, again, creating a product is not an isolated activity. There's a lot of collaboration and interaction happening. If you have something to show to your customers, that's a very big advantage because right in earlier stages, you can try to understand what may be going wrong with the product or where is the potential danger that the project might fall off the trajectory. Because when you interact with your customers or clients, they will give you review, they will sort of bring you back on the track. Like I've been talking to the teams for the past 2 days. Today also I will have meeting. So and we have been talking about problem understanding. And even from that interaction, it appears that as your understanding of the problem will improve, definitely the prototype that you will create will improve and it will be reflected in that. And that is why this prototype is basically a tool to enhance the interaction between the developers and the other people who are concerned and keep this channel of feedback open so that very rich information can flow from the end users and customers to the developers, which can help them to develop much more richer applications and products. So that is why software prototype is very, very important, and it helps in evolution of the product and its requirements. And again, it is based on the philosophy that as humans, we are tuned to act and behave in certain situations in which we can really interact with the things around and then we can give the proper feedback. So that is why I hope you understand from this brief discussion the importance of creating the software prototype. And it doesn't have to be something really groundbreaking or something that makes the headlines, nothing like that, just functional piece of software which is doing the basic things you expect from the software based on the requirement analysis that you have done. So I'm again putting this image in front of you because it shows, first of all, that lack of communication and lack of collaboration can lead to development of a product which was entirely very different from what the customer needed. But how would this big change if the prototype was introduced into this? So it just a way to show that the situation may not have been that drastically different if prototype would have been developed. So that is why when you are at the helm of developing a product or any module of it, you must take a sort of ownership on it and stay in touch with it and then definitely interact with, if you are in a software development environment, you would like to interact with your senior team members or your manager, your technical manager. Sometimes if UX is involved, you would like to talk to UX also. So these kind of things are extremely important. This is the basic philosophy of software prototyping. You try to build, you evaluate it. Now again, when we say measure, you need to understand on what parameters you will evaluate your prototype. So creating prototype is not enough. Once you create the prototype and you share it with people to evaluate it based on their comments, you should have a template ready with you because you definitely have some questions that you are trying to ask from the prototype. So when you give the prototype to the user, based on their feedback, you try to understand what are the questions they are raising, and if your prototype is able to tackle the questions that you wanted it to tackle. So you need to know that once you out sort of broadcast your prototype for review or pilot it for review among certain members, um, your work is not done. You cannot just sit back in a relaxed manner. You have to actively participate in the feedback your people are giving. So that way, measuring is not enough. You need to know what you will measure. You need to know what you will evaluate and how you will evaluate. Then only when you find some gap, some limitation in the software prototype, then only you can learn and then try to improvise it on again. So basically, software development is the process of improvising through gaining feedback and constructive criticism and review. So this circle keeps on going unless and until you are ready with the final product. But before we talk about the different types of software prototyping, I want to understand from you because we literally throw words like POC, proof of concept, software prototype, minimal viable product, uh, very carelessly. So it is important to understand what is the difference between these three words. So what do you think is the difference between software prototype or POC and a minimal viable product? What do you think? So let us talk about POC. How is POC different from a prototype?
Uh, in POC, we just show that whatever we are thinking is right. We don't do it completely. We just show it. It happens. When we do something will happen. We just show it. And
Okay,
in prototype, we design it and we let them interact and let's know what are the difficulties or what we can do with it.
yes. Thank you, Tarun. The response is really quite good. Anyone else who wants to share what is their understanding of the difference between POC and a software prototype?
So,
Yes?
am I audible?
Not quite.
Yes, ma'am. Ma'am, POC is idea on which we are working, whether that idea is feasible or not, implementation wise. And prototype means how it will be done, the idea or software we are planning to implement or deploying, how it will be done, final view of that product.
Okay, okay. Thank you, David. Anyone else? So your classmates have attempted to explain and they're quite successful. And so next question that comes is how is software prototype different from a minimum viable product? So what's the difference between software prototype and MVP?
Ma'am, it lacks scalability.
Which one?
It cannot store more than it cannot store more data.
What is it?
Loads of data. What is it?
What is it?
I didn't understand.
So, you are saying it cannot store more data, and I'm trying to understand what you refer to it by, either it's prototype or MVP.
I can't recall it right now.
Okay. but based on your understanding, because what is the core difference between a software prototype and MVP? Prasad is mentioning POC is basically checking whether a functionality can be achieved or a concept is viable or not. Prototype is a small scale project encompassing, if not many, some functionalities so of the product. So minimum viable product is again a step after software prototype. Basically, it is launched in the market to see the reviews of actual end users. So POC is generally used to understand when we are trying to understand the feasibility of a concept. So for example, you are trying to create a fall detection algorithm using motion sensors and infrared sensors. Okay, so before obviously you create something very tangible which can be mass produced, you want to see that whether the concept of using motion sensors and IR sensors for fall detection for elderly people who are living alone is feasible or not. Does it really make sense? So how do you gauge that using the information you gather from the movement of the person in the house and how his or her movement are getting captured through these sensors, and whether or not over the period of time you can read from his or her data collected by sensors, or predict whether the person will fall due to his or her certain gait movements or something like that. So to understand whether a concept is really feasible at a small scale, you try to create POC. So normally in software industries, there is a branch of R&D. So they are always working on new technologies, new concepts to be introduced into the market. So before a development team can be, sort of given the responsibility of working on that product or the idea, the the creators of that idea pitch in that idea by creating POC and demonstrating it to the entire team. When the team is convinced of some weight in that idea, then they will be taking it seriously and going towards the prototypical model. So let's take another example of POC. So for example, you are trying to create an engine, a recommendation engine for exercise for people based on their history of exercises and the pattern of sleep and the eating habits, let's say. So you're trying to understand how the information from these three vectors, exercise, food, and sleep, can be used to customize the plan of exercise plans of the users. So this is also a concept. So to test this concept, you would ideally create a POC so that first of all you can see whether the concept that you are thinking is really making sense or not and how to go about it. So basically POC, as it means, it's a proof of concept. You have some concept in your mind, you try to prove it or disprove it. So normally in ideations, especially in software industries, a POC making is very, very prominent. Software prototyping, on the other hand, means or shows that you have understood the problem that you're trying to solve. You have gathered a set of requirements. But it is always important to remember that it is impossible to gather in requirements 100% at the starting stage, because as you proceed in the project development, you gain more clarity and your requirements are refined. Minimum viable product is something which is usually used in business, and so mostly graduates who are studying business administration, they are generally talking in these terms of MVP, mostly in the subjects of entrepreneurship, when they are trying to launch a new product in the market and then try to see. So software prototype is still very software sided, very development sided, in which you're trying to check some functionalities. Meanwhile, viable product will contain functions also and other aspects also which can sort of encourage the customers to buy. So they are trying to understand the purchasing uh, purchasing desire of the customers and how that product might create some sort of stimulation in the customers. So just to revise, so proof of concept is usually, as you have mentioned, a short-term project aimed at proving the validity of the concept. So any idea that has ever seen the morning light has emerged from a concept. So there's a journey that goes from POC to prototype to MVP. So POC, if the POC shows that the idea is not feasible, it will not go forward. So it shows the feasibility of the idea and the possibility of achieving assumed business results. You should always remember that anything anyone creates, any software development project or any app, ultimately they are trying to make a business out of it. Not everyone, but ultimately the idea is to engage the customers. So it has to start in steps because uh, if it's not working according to the plan, then you sort of get warned in the earlier stages before you have invested heavily in those resources at that time. So POC serves exactly that. So a small project is implemented to just for the testing of the concepts and technical capabilities, and it is relatively faster to develop the POC and helps us to get a sneak peek into our own mind and our own thinking that whether we are thinking right about the concept or not. The prototype, on the other hand, is a first-hand visualization of the product that the image of the product that is in the mind of the developer. So again, the main idea, the prototype is shared with a set of people is to identify errors and mistakes in the first level implementation. And then you can test your product design, usability and functionality. And then slowly build upon that, learning from the prototype. So it is mostly like a trial version of the product, but not necessarily a market ready trial version of the product. When we talk about market ready or less than market ready, then it has to be much more than we come to minimum viable product. It's a product in early development with minimum set of kits that is sufficient to launch it on the market for customers seeking an initial evaluation. So proof of concept is testing the feasibility of the concept. The prototype is testing the usability and functionality of the software piece. The minimum viable product is actually seeking an initial evaluation of customers of the product, which is sort of launched in the market. So, in comparison to the prototype, which may be piloted to among few people, minimum viable product necessarily does not relate only to the pilot set of people, but actually to a larger audience, wherein you can actually gauge the sentiments of people about that product that is being launched. So in MVP, what you are doing is that you have understood that your concept has some heft to it, and then you actually bring it into the market to test your business ideas against the real hard numbers generated by real customers. So, for example, in the first year in the entrepreneurship class, a group actually made a minimum viable product of generating data visualization of COVID data. So they actually created this product on Telegram, and so this could be called as a minimum viable product because they had actually shared it with rest of others for the testing phase. So for that, the functionalities, the system was supposed to provide data visualization, and in that manner, it was somewhat near to the actual product, and this could be called as the MVP. So one of the examples of MVP is Twitter. So long before Twitter was launched, the originators actually created the features of the idea and tested them on some limited group of users. And so currently, I'm not sure Twitter allows 140 characters, I think, but they had tested it, the MVP, with 160 characters, And after a series of successful tests, then finally Twitter was launched. So even for social networking sites, earlier, I think, I'm not sure if you remember, before even Facebook, there was another social networking site. Do you remember its name?
MySpace.
MySpace. And there was something else also from, oh, I'm not able to recall its Orkut. Yes, Orkut. So all these software networking, websites, they are not just suddenly launched into the market. Even for WhatsApp, Instagram, and what is that? Snapchat. So all these products that are launched in the market, the creators always develop a minimum viable product. They test it on the set of users. In fact, there is another website which allows students from all over the world studying in the universities to interact with the students of other universities in all over the place. So right now it is on the testing phase, but it is already up on the internet. So from this also, what they are trying to understand is they are going beyond the functionality and usability and directly engaging with the customers who will be finally interacting with that product. So see, it's very important not to use terms very loosely because all these terms have a certain meaning. So going forward, just be careful of the way you use the word POC, the way you use the word prototype, and the way you use the word MVP. They are not isolated from each other, but they are very, very different from each other. So I thought that that distinction was important to understand before we go to software prototyping. So have a good look at this 2D plot and let me know from understanding from your understanding, what do you understand when you look at this plot? And have a good look at the X and Y axis also. So when you look at this, what exactly do you understand?
As time progresses, POC can convert into a product.
Okay. Right. And what about the other aspects? Thank you. Anyone else wants to try? What do they understand when they look at this graphic? Also pay attention to the y-axis. Come on, who wants to try to interpret? Then otherwise I'll have to ask the names.
Someone message.
Go on. Yes. So Prasad says relation of deployment and development. So where do you see deployment here and development here, Prasad? If you could elaborate on that. So I think the theoretical discussion we had on the difference between POC, MVP, and software prototype is a bit clear using this 2D plot, which actually shows that so the time spent to develop a POC is lesser than that used for prototype and so on. And POC is generally used at the analysis scale. So at the analysis phase, this is what is happening. The POC is used for the analysis of the concept. Once you know that the POC has obtained a green flag, then you can normally move on to the prototype. So prototype is I'm not saying it's a logical next step, logical sequential steps to POC. That's not what I'm saying. It just shows the relationship between all these aspects in the software product development. So prototype takes considerably. So it's a relative graph. Prototype relatively takes more time than POC, and it's not just for analysis, but it's actually simulating the system that the developers are intending to create. So it's a next step beyond a POC. MVP on the other hand, and the size of the circles is demonstrative of the impact of these things. So MVP relatively takes much more time than POC and prototype, and it automatically has covered the analysis and system simulation, but its prime objective is to it's basically a draft system for the customer. So the customer will be directly interacting with this minimum viable product. And once all these things are done, then finally the software is put into the production where it emerges as a full system, and it can take years. So this is sort of a journey that explains. So hopefully now you will not use the terms POC, prototype, and MVP interchangeably. They are very, very different from each other and have a very different place in the software development. So from this, hopefully, that was a sort of digression, but the idea was to make you understand POC, software prototype, and MVP before we actually delve deeper into software prototyping. And from the importance of software prototyping, it is clear to us that writing a strategy is not enough. We should definitely create a prototype. And you see, it's not only important in development circles, but also so suppose if you tomorrow you are starting your own company, and you are trying to create a product, and then you are seeking out venture capitalists who can fund your idea or product, then you cannot just talk to them in theoretical terms. So usually in business meetings, there are someone called as business analysts, then product managers and coders and developers. So what happens in this kind of meeting is that usually they are very strictly time bound. But in that time, you have to literally equip the people who will be funding your product or venture with what exactly your work will do. Sometimes, mostly people who are in these meetings, they may not have a fully working code, but sometimes they make the interface to the interface of the solution, which can always be implemented later. So sometimes there are also called as design prototypes, in which they want to show that how the system will look, how it will interact. They have not developed the backend, but even that type of prototypes are quite common in business meetings. Because again, as I told, human mind is wired to see, interact visually, and then perceive, and then make a decision. So that is why prototypes are quite important. So naturally, a question might arise in your mind that isn't working on prototype expensive, or doesn't it involve additional costs? But to minimize the error over the period of time and to enhance the survival rate of the software, a prototype is necessary because it sort of keeps the overall development cost lower. Think of the London ambulance service example. Do you think they actually created any prototype before launching of the services? I'm sure you would have read
No.
something, but yes.
No.
Okay. So, is the answer categorically no, or did they actually uh, create some system and then tested it before actually launching it? So you see, not developing the prototype can be very costly.
They actually have so less time, so they just made it and used on the go, which made that people are not were not well trained. Also, uh, the system is full of latency, so I think they haven't made a prototype and tested it on a smaller scale. They just implemented it, which made life costs. I mean,
Yeah,
which cost life.
which cost them a lot over the period of time. And yes, Anidya, unit testing was there, but integration testing was not really performed. But just imagine the loss that could have been averted if they would have created a prototype or even MVP and tried to see how it's working before actually making the service public to all the people. So naturally, these things, yes, these things can create a very huge hole in the reputation of the company also. And that is why prototyping not only helps in taking cautious steps, but can avert lots of mistakes that might occur in the future because of short-sightedness. So, and London Ambulance Service is just one example of how software engineering, that computer-aided dispatch system went wrong on a large scale. There were many other reasons behind it. But all the things that you are mentioning, that they rushed for deployment, the integration testing was not there, critical situations were not considered. So again, the review was considerably missing, the staff training was also missing. But just imagine how the situation may have been different if prototype would have been developed. Now think of before the spaceships are launched. So before the spaceships are launched in the space, they always test, they always create a prototype, they always test in a simulated environment. Why? Because they know that the cost of failure there is very, very, very high. Sometimes the attitude of people to software prototyping is considerably influenced by their understanding of the cost of the failure involved. If they see that the software failure, if it happens, will not be too costly, then they may not bother about software prototyping. But if they see that if the final product somehow goes haywire, then the damage it will do, and sometimes permanently, will be quite huge. So based on the criticality of the system also, whether it's a large scale product or small scale, and the risks associated with the failure, that motivates software prototyping. Humans by psychology are, although I don't feel good in saying this, but motivated by fear. So if the fear of software cracking much later is high, then definitely that prototype approach is there. So you need to know very well the costs associated with a failed system, because prototyping involves efforts, it involves time, and it involves resources. Okay, but because software development is like an inverted pyramid wherein every successive scale is dependent on the previous scale, then definitely it helps in the long term. So wherever you are, anywhere, just don't mindlessly create the software prototype. Assess whether assess the trade-off between the time and resources, whether the software prototype needs to be created, and what do I stand to lose if I don't create, and what I can potentially take care of if I create the software prototype. So just because you know the term software prototype doesn't mean that you create it mindlessly. You should spend good amount of time trying to understand whether it will be beneficial in the long term or not, and that you can only assess when you have understood the problem you are solving, the solution you are creating, and the impact of that solution on the circle which will be using it. So all these decisions definitely influence the prototype. And even after prototype, lots of failures happen, but the extent is quite less, because the extent would have been more if the prototype would not have been created. So that is why software prototyping, uh, you should not blindlessly go into software prototyping or any other thing for that matter. You should have a proper reason as to why software prototyping is necessary. So broadly, there are three types of software prototypes: throwaway, incremental, and evolutionary. In our next class, we will see the examples of all these three types of software prototypes in detail and try to understand what distinguishes them from one another, and also try to link software prototype types to the software development life cycle that we have studied. So that we will discuss in our next class. So that was all for today. Hopefully the background for software prototyping was laid, differences made clear. The importance of software prototyping, I hope you have understood. But again, it differs from product to product, the stakes associated with the software product. Because creating prototype is not a joke, it involves cost also in terms of time. So in next class, we will try to understand the different types of software prototypes and some examples of them to enhance our understanding of software prototyping. Thank you so much. If there are any questions, I would be happy to answer. And again,